It begins like a rumor whispered by the vacuum itself, a point of light on a hyperbolic leash, cold as a cathedral floor and yet strangely warm where it should be silent, threading through the solar system with the composure of something that has crossed many dawns before ours. We give it a name because naming is how we make room for awe. 3I Atlas. And we stack numbers beneath that name because measurement is how awe matures into science. The orbit is unmistakable, the excess speed beyond the sun's fall undeniable, and the geometry of its arrival is the kind storytellers prefer to call fate, and physicists prefer to call initial conditions. What lingers after the crisp lines of ephemerides have been drafted is a murmur in the data. An infrared plateau where the thermal curve should have dipped, a phase response that clings to equilibrium like a swimmer that never quite leaves the shallows, not hot, not cold, but held to a temperature as if some hidden hand were smoothing the fluctuations of day and night into a single controlled hum. The night sky is full of stones and ice that blaze and freeze as they turn. This one seems to breathe. The discovery is administrative in the beginning, flagged by the survey that raises its net over the dusk, stamped by computers trained to notice when the sky draws a line that isn't bound to return. But an interstellar designation is more than a bureaucratic triumph. It is a statement about history. The first time we traced such a path, we invented a word, interstellar, and stitched it to a Hawaiian name that meant messenger. The second time, we saw a comet more comfortable in the language of dust and gas, and we settled into the idea that the galaxy occasionally lends us its debris. The third time is different. 3I speaks first, not in ice nor in reflected brightness alone, but in heat. Soft, stubborn, quietly regulated heat. The early nights show a light curve with modest variability and a spectral signature that refuses to spike into the cryogenic extremes we expect of something tumbling between sunfire and starlight. A less poetic observer might say the thermal inertia is too high. A more philosophical one might say the object prefers a constant self. Between those sentences lies a hypothesis you can taste on the air, that the heat is being managed. What then are we actually seeing when telescopes whisper of a thermal damper? Begin with the ordinary choreography. Sunlight falls, photons are absorbed, the surface warms on the day side and cools on the night side, the object rotates, the temperature lags and leads, and over hours a comet or asteroid sketches a thermal syllable we can learn to read. For rock and ice, this syllable is erratic, sharpened by outgassing jets or softened by dusty mantles, but always the system is negotiating, not dictating. Here, the negotiation appears biased toward calm. Mid-infrared data imply a narrower distribution of temperatures than an irregular, slowly rotating body would naturally wear. Radiative efficiency seems tuned. Emissivity across bands acts as if selected. No single number is outre. Each can be explained by albedo, by microtexture, by porosity. Yet the ensemble conducts a more difficult symphony. The day side does not overheat as much as predicted. The night side does not grow as cold. The result is an object that watches the sun and responds like a seasoned traveler who carries a cloak. An instrumented cloak is an old dream in spacecraft design. Engineers speak of heat pipes and phase change materials that shunt energy from where it pools to where it is scarce. They speak of metamaterial skins whose patterned lattices accept particular wavelengths and refuse others, of radiator fins tuned to a planet's infrared, of louvers that iris open under thermal load and close when the chill creeps in. If you gave such artisans a lump of cosmos and asked them to carve a traveler that could pass close to a star without boiling its heart, they would give you a thing that looks ordinary at dusk and yet maintains its core as steadily as a heartbeat under a heavy coat. This is the whisper in 3I's data. Not that it glows with excess, not that it hides a furnace, but that it behaves like a body with an opinion about its own temperature, as though some network of thermal pathways, whether microfractures filled with volatile frost or capillaries of engineered conduits, carries heat with more wisdom than chance. There is a caution we must adopt in all this. Our first interstellar visitor taught us how easily surprise can masquerade as intention. An elongated shard, a low albedo, a rotating slab that brightened without shouting in gas. We learned to suspect hydrogen ice, to suspect nitrogen sheaths, to suspect dust mantles thin enough to confuse our thermal senses. But as careful as those hypotheses were, they struggled against the constraints thrown down by observation. Cometary models that require outgassing but hide the gases. Radiative models that demand surfaces both reflective and absorbing. Geometry that resists simple fracture. Res albedo evolution. Spins that should tumble but don't. The lesson from then is humility. No single mechanism need be true. Nature can stack many. The lesson from now is symmetry. The numbers we are gathering for 3i fit many little mechanisms if you squint, yet the small mechanisms conspire in their sum toward an animal-like stability. In orbital dynamics, we often celebrate conserved quantities. What 3i seems to conserve, much more than angular momentum or eccentricity, is comfort. Consider the faint non-gravitational acceleration. It is there, then gone, then unmistakably there again, in fits subtle enough to be smudges where our ephemerides sloppy. The canonical explanation wears a comet's cowl. Jets of sublimating gas push gently as sunlight sharpens their moods. But the jets want to shout in spectroscopy. They prefer to leave fingerprints in CO, CO2, H2O, or dust that gleams at wavelengths our instruments are hungry for. If the jets are there, they are parsimonious and well-placed, as if they knew the vector we require for a specific course correction. Otherwise, another explanation waits patiently. Thermal recoil forces in bodies with crafted emissivity maps. Paint one hemisphere bright and the other dark, sculpt microstructures that radiate more here and less there, and the anisotropic photon exhaust pushes like a long breath. The Yarkovsky effect, this dance between sunshine and spin, is a naturalist's delight in asteroids. In a body whose surface is a deliberate quilt of emissivity zones, it becomes a rudder. Even in the constraint of spectra, there is space for mystery. We do not see the water coma that would approve a garden variety comet. We do not see significant carbon monoxide. The CO2 lines, where they appear at all, refuse to climb beyond a thin mist. Instead, we see a continuum that suggests a mixed surface, powders of silicate glass beaten by eons of micrometeorites, perhaps, braided with organics that absorb blue and wink red, set upon a bed whose pores are either sealed or so narrow that sublimation is a rumor rather than a wind. A thermal damper could be natural in such a lattice. Fine regolith conducts poorly. Phase changes in trapped ices blur the peaks and troughs of temperature, and fractures guide heat like veins. But the neatness here is unexpected. Rotation rate estimates cut against rapid tumbling, as if the body maintains an attitude comfortable for control. Phase curves have shallower amplitude than expected, as if the limbs of the object glow with a warmth borrowed from a noon that never quite arrives. In engineering, such features are designed into skins and panels. In geology, such features are the emergent property of long accidents. The burden of proof is heavy, but the pattern is tempting. The temptation grows as we chart the geometry of arrival. The hyperbolic excess velocity is not exotic in its magnitude, but the inbound vector threads the ecliptic at an angle that, through no intent of our own, maximizes our ability to observe while minimizing the wear and glare of solar interference during key phases. If you were plotting a tourist's tour through a system, you might not choose such perfection, but you would nod at it with professional respect. Early passes by the outer planet's gravitational fields are avoided by margins convenient for a ship that prefers not to be perturbed. The perihelion distance is generous enough to spare extreme heating, yet close enough to offer excellent radiative load for any test of a heat management design. The outbound leg offers alignments with two of our high-sensitivity observatories' night schedules, as if a mission profile kept one eye on when we would be watching. Coincidence is a rich soil in a universe of innumerable lines. This is still a garden worth walking slowly through. Walk slowly, and you notice the cadence of tiny slingshots. There is no bold swoop by Jupiter, no brash handshake with Saturn's bulk. Instead, low-amplitude gravitational perturbers, our motley collection of small bodies and planetary tidal fields encountered obliquely, offer touches of momentum that are neither dramatic nor negligible. These touches are the sort of thing nature distributes recklessly. They are also the sort of thing an interstellar navigator could exploit to trim a course for efficiency, or at least to ride the stray winds without fuss. Orbital integration runs hint that small shifts in outbound asymptote could be achieved with minute timing at perihelion, and if indeed those minute pushes correlate with the phases of the object's subtle thermal recoil, we could be watching the galaxy's oldest trick, sailing, not on gas, not on plasma, but on light, the gentle pressure of photons on a surface engineered to accept pressure in one direction and leak it in another. A heat map is a sail turned inward. A photon sail is a heat map turned outward. The mathematics that unite them is patient and elegant. There is a quiet scandal we have to discuss, though scandal is too loud a word and suspicion too sharp. During a brief window near Superior Conjunction, 3I slipped from our most sensitive instrument's gaze. This is normal. The sun is a tyrant in optical work, and a bright tyrant at that. The scandal is the rumor that data exist for that window in another band, captured by an asset not typically listed on astronomical proposals, where the thermal signature would have loomed untroubled by glare. The rumor says the signature was present and then less present than expected, as if the radiator array, if such a thing exists, drew a curtain. The rumor is likely wrong, because rumors prefer drama over calibration. But between the stutter of our instruments and the cadence of solar interference, a human thing grows. The desire to believe that something looked back and closed its shutters, not to hide, but to remain measured. Science must be immune to that desire. Scientists are permitted to feel it like weather passing over the skin. Even without secrets, the implications are severe. If 3I is natural, we have learned that interstellar geology writes subtler poetry than we imagine, that the rubble of other suns can brew a microstructure of pores and veins that cap and decap ice sublimation with precision, that heat can be choreographed by fracture and dust alone, that nature can build radiators by accident across millions of years of micrometeorite gardening. That discovery would export to our designs. We would pattern our spacecraft skins on regolith geometries. We would print structures that mimic asteroid pores. We would use vacuum ovens to teach materials the language of silent, steady warmth. If 3I is not natural, if it carries some signature of governance, some layout of heat-spreading channels and emissive grids that could not arise in a glacier that learned to fly, then we are not watching a traveler. We are watching craft, not a beacon that shouts hello, not a chariot streaking under fusion, but a patient courier whose mastery is in refusal. Refusal to waste heat, refusal to squander momentum, refusal to declare a chemical anthem when photons suffice. We are, in that case, learning pedagogy from the galaxy itself. A technological civilization that lives long must learn to be mild with its energy. Heat is a brutal teacher. Any engine leaks it. Any metabolism signs it. Any city glows as if it has been touched by a small sun. To survive the patrols of entropy and time, the wise grow modest in their signatures. A body that arrives wearing a cloak of thermal moderation is saying, we are past the phase of fireworks. It is also saying, light is enough. Sail, thermal rudder, controlled emissivity. The triad points to a school of engineering that treats momentum and heat as currencies precious enough to budget closely. Our detectors, so often trained to notice the explosive, the comet that vents like a kettle, the nova that blares, are now being tuned by necessity to notice composure. In that tuning lies a cultural shift. We will build instruments that can sense the difference between a shadow that shrugs and a shadow that breathes. The first missions shaped by this insight will be modest as all beginnings are, a convoy of small sentinels propelled by sunlight. their skins layered with metamaterial lattices that learn from what we've seen in Three Eyes Quiet, will inflate from chemical rockets like the walls of a paper lantern pushed gently by a hand. They will station themselves high above the ecliptic to watch the inbound traffic lanes from the dark. They will share data with each other as much as with us, because we will have learned that networks see what single observers miss. They will be patient. When the fourth interstellar visitor arrives, and it will, because the galaxy is both generous and messy, they will measure its heat not as a number, but as a path, the way you would trace a bird's migration by the rhythm of its beats. If the fourth confirms the third, and if the fifth arrives wearing the same cloak, then a pattern will harden, and we will consider, without embarrassment, that some fraction of these visitors are instruments in their own right. There is a future in which we do more than watch. We will prepare a craft whose engines are literal light, a sail with a heart of sensors and a brain too careful to be betrayed by its own waste heat. It will not chase with brute force. It will loiter in the dark lanes where the interstellar drift runs fastest and wait with the courtesy of a fisherman. When the next object approaches, our sail will lean into the photon wind, shape its thermal signature for thrust as an oarsman shapes his stroke, and ease into formation beside the traveler. No docking, no capture, just companionship at a safe speed, separated by a few kilometers and a silence that is almost reverence. For weeks we will ride the same curve, measuring whispers, micro variations in heat, the resilience of a surface under small solar storms, the way the object argues with the sun. If it speaks in gases, we will taste them. If it speaks only in photons, we will listen there. The probe will know when to leave. We will have taught it to respect the privacy of a curtain if one is drawn. And it will sail home not with a trophy, but with a story told in fine structure. What then of meaning, the human signature on all this? There will be voices that demand an answer stamped with a noun, natural or artificial. There will be budgets and committees and 1,000 pages of risk, and they will be right to demand parsimony because evidence deserves no less. But there will also be those for whom the distinction softens in the presence of a larger lesson. Natural or artificial, 3, I demonstrates a principle that should guide us as surely as any creed. That mastery consists in harmony with the field one moves through. A fisherman who reads currents, a glider that surfs thermals, a craft that lets light do most of the work while it arranges its heat like a musician arranges timbre, these are kindred arts. If we call it alien design, we are recognizing the alignment of means and ends with a delicacy we have yet to cultivate at scale. If we call it geology, we are admitting we have underestimated the craft in stone. I want to return, before we close, to the opening image, a point of light held between extremes, maintaining a quiet heart while crossing the furnace and the abyss. There is a philosophy hidden in that, one that Brian might unpack by reminding us that the universe is a machine for making complexity in defiance of chaos, and one that Michio might celebrate by imagining futures where our cities wear skins that drink and shed light with the same poise. Physics is not merely a ledger of permitted moves, it is a grammar of grace when used with care. The thermal damper, if that is indeed what we are seeing, is not a flourish. It is grammar obeyed exquisitely and grammar used as art. If a civilization has sent it, they have chosen to be elegant. If the galaxy has sculpted it, it has chosen, through the blind chisels of time and chance, to suggest that elegance is an attractor in the space of possibilities. And so we watch. We watch with instruments that have learned to respect subtlety, with models that admit their priors, with language that refuses both to lie and to belittle wonder. We watch because the third visitor speaks in the key of moderation, and moderation has always been a hard teacher for a species drunk on brightness. Perhaps that is the gift 3i brings as it threads out again into the night, a syllabus for res. Traint. If we learn it, the ships we build will be at peace with their own warmth. Their sails will be woven from light, and their signatures will be the kind of music that does not wake a sleeping house. We will not pound on the doors of other suns. We will arrive like a tide. And when years from now, some other civilization's astronomers notice a point of light whose thermal curve is calm where it should be wild. Perhaps they will tell a story about us, and perhaps they will choose a word for us the way we chose interstellar, a word that means traveler and student and neighbor. We will have earned that word if we remember what this moment has taught, that the universe is a place where quiet is not absence but control, where heat can be shepherded without flamboyance, where a path through gravity can be drawn with grace as one draws a bow across string. The data will be argued over, the models will be refined, the rumors will die the appropriate deaths of rumors. What will remain is an alteration in posture. We will raise instruments that can tell a radiator from a rock by the way it sighs. We will think of emissivity maps as sails in miniature, and we will plan rendezvous not as chases, but as dances. From such small changes in habit grow the futures we like to draw in our heads. Cities that slip their heat into the night as a whisper, spacecraft that spend decades gliding on photon tides, and the eventual courage to lift our eyes from the ledger and call it beautiful. Not because it flatters us, but because it teaches us a better way to move. There will be consequences in theory as well. Thermodynamics, that stern judge, will not be kinder because we waxed poetic. It will demand that everything we infer about 3I's thermal moderation be accounted for in entropy and energy flow. That is good. Let our equations grow more precise around emissivity gradients. Let our computational fluid dynamics for sublimation models include pore networks with percolation thresholds we once ignored. Let our radiative transfer codes borrow tricks from the engineers of spacecraft skins. In meeting those demands, we will discover tools worth having regardless of what 3I is. The mathematics of moderation will help us climate our cities and cool our chips. The material science of metamaterial radiators will cloak habitats from Mars to Europa. The orbital strategies that treat light as a fuel will open the slow highways between stars. We will have been changed by a visitor that may never have intended to teach us at all. And if intention was there, if some far intelligence designed this traveler to be seen, not by its brightness, but by its steadiness, what then? We answer in kind. We build not a reply that shouts, but a reply that can be recognized by any who read the grammar of physics. A craft whose presence is small, whose patience is large, whose heat is composed. We send it not to chase, but to accompany, and we measure without prying. Our message, inscribed not in radio, but in the conduct of the mission itself, would be simple. We understand that the universe prefers composure. We are learning to move with it. If they are out there, that will be enough. If they are not, it will still have been right. In the end, we place this story back where it belongs, among the stars and the instruments and the people who keep them humming in the cold hours before dawn. A survey telescope saw a point, and teams gathered, and models grew like frost on windows in winter, intricate and honest. The conclusion is not a verdict, it is a widening. A third interstellar object has taught us to look for the signature of intention not in noise and flamboyance, but in the carving away of both. Whether the sculptor is time or mind is a question we will be happy to ask with better tools. Either way, the solar system is no longer a quiet cul-de-sac where dust drifts and nothing passes but the wind. It is a harbor, and out beyond its breakwater run shipping lanes we are only beginning to chart. We will join them, we will go gently, and our wake will be a line of moderated heat written with care across the dark,